the lucky 71 people here, because we're going to talk a little bit about what's going on behind the scenes at Opentensor. Let's go back down memory lane. So in December, we proposed the DTAO solution. And I think at the time when we proposed it, I don't think a lot of people really understood why. Maybe if you were really, really paying attention to the way in which the subnetworks were set up and the way in which we were distributing emission, and you were seeing how things were progressing, you would have understood, I think, why DTAO was so required. But I think that now a lot of people understand the need for a solution to the emission distribution that does not come from the root network. I wish I could say, hey, everyone put up your hands if you agree. But I think it kind of goes without saying. And there's some current conversations about this particular topic on Twitter right now. Bad English Tea is out there, saying that we should set weights into the root network, which would, by the way, if you set weights onto the root network itself from the root network, that decreases emission. And I think that we're at 7%. I think it's around 7% of emission that's actually being dropped out of the network, which reflects people's sense that we need to decrease the amount of emission that's going across the subnets while maybe they're setting their incentive schedules up and we're not getting bang for buck for tau. That mechanism was put in place specifically for this purpose. But with DTAO, one of the really nice things about the design that we are pushing forward is that if there are subnets which are inefficient, the miners are just selling and not producing any value, that actually comes out in the price of the subnet, which then in turn determines the emission. So we can shelter the inflation of tau using market dynamics, access to the subnets being the primary determiner of that price. Now, that's kind of a segue for you, Victor, because of course we're going to be talking about how your subnet is producing value, and you have some really interesting mathematical equations that you have in a presentation to showcase how you're doing there's a relationship between tau holdings and bandwidth in your subnet specifically. Let's go there and talk about this particular solution that you've put together on NicheNet. It's one of the first subnets that was ever created. I know that you were working on this before the Revolution upgrade. So like September or so, you were working on the subnet specifically because you had got access to the Bittensor subnet template long before it was sort of launched and you could do things on mainnet. And you would transition from being primarily a miner to building subnets specifically because you thought you could do a really good job. And that was around the time that we were fixing holes in the subnet 1 mechanism and you were part of breaking that mechanism. But let's take ourselves back to the very, very beginning. Where did the idea come from for this subnet specifically, Victor? And why did you think it was required to build?
Thank you very much for that intro. So there was a few difficult challenges for creating an incentivized subnet, and one of them is, okay, how do we benefit from having multiple actors participate and not have it be an advantage to just find one solution that one miner uses and takes over the network? The second challenge is, okay, how can we produce value for each validator so that we can basically maximize the access to the network and the value they can derive based on their tau, because otherwise, why would you prefer a bigger validator over a smaller one? So I've put together a little bit of a presentation to go over these points, our solutions to that. Yeah, I'm trying to share screen, but it doesn't seem to actually let me. I'll let it load, but in the meantime, I can start a presentation. So our subnet basically is founded on the idea: what if we could make AI universally accessible and tailored to each individual's niche? So we created an inference subnet for running the best generative AI models for each niche. And this is a way to make it accessible, affordable, and tailor-made.
Wait, before you continue, Victor, what is niche, and where does the name come from, and what do you mean by that?
Oh, absolutely. So niche came from the idea that Subnet 1, it had basically the idea that there should be like one general AI. Everyone should run like a model that answers the same type of questions and gets as good as possible at this task. So I was thinking, but is there just one task that is one type of model that is the best for everything? Maybe if we create a network where everyone had different specialized models, we could get a lot of synergy of these different like categories or niches that makes the overall network more intelligent. So, for example, when it comes to image AI, we can divide it into a few categories. For example, we can have realistic images that like look as real as possible. Then we can have animated images, which is very popular. It can be kind of like goofy or just nice illustrations. But we also have things like, okay, do we want a really fast model, a really cheap model, or do we just care about the topmost quality? So by having different niches for the models, both when it comes to this the output, but also the way it is produced, meaning price and speed, we can create an overall network that is much more intelligent as well as flexible for different use cases. And actually, it seems like it's going to let me share my screen now. So I'm going to go ahead and do that. I've prepared some visual aid for this. But first of all, did that answer your first question?
It did. It's about having different types of models. So like stimulating diversity, and that in that diversity, you can improve the value add of the subnet specifically. Mr. Niche? Maybe his screen is loading here and he's taking a little bit of time.
Hey, I think we
can see
for a second.
We can see your screen.
Hey, sorry, I dropped for a second. Great that you can see the screen. What's the last thing you said?
I said nice slides.
Oh, thanks. So yeah, here you can see these are this is the same prompt generated with 4 different images, and they have different costs, different speeds, and also slightly different output. So we started out with having these fixed models, where we, instead of anyone being able to run any model, we wanted to have some consistency. So that's why we started with saying like, oh, you should run one of these 3 models. And we expanded that to now 7 models. And we can just check 1% of the output. Like, oh, is this miner running the correct model? And we can say, oh yeah, it's correct. And then you're only competing as a miner with the people running the same model as you, which means it's kind of like a subnet within the subnets. So you see like, oh, the people running Dreamshaper, this one is generated by Dreamshaper, they have a problem fulfilling all their requests. So let's give some more emission to that one. That means more miners will be running this model, scaling up the volume of images we can get from that. So that makes it very adaptable based on demand. If it comes something new, we can start by implementing it and give it very, very little emission, like 1%. Then if we see like, oh, it's working well, we scale it up to 5%, 10%. And if something doesn't work well, we can just set it right back down to 1% or remove it completely. So it's kind of flexible in that way to have the different subnets.
And a validator is able to set this specific emission distribution directly, right? So they can say, okay, I want 1% on 4 and 99% on 1, and the miner should adapt to that landscape?
So that's not how it's working currently. Currently, all the validators have like the same access to all miners, and Emission is currently centralized. We're talking with validators, but for now, we have like more rate limit than we need. So it's kind of easy to give Emission to models. But yeah, long term, we want to kind of decentralize both what validators want to run or want to be run, but also to make it possible for miners to add new models. But right now it's kind of centralized, so we update on a weekly basis the Emission based on demand.
And these are terms set by the owners effectively. It's pre-coded into the validators by the owner key, or you could say via the GitHub.
Yeah.
And what is this?
Could change it, but it would.
What is this current distribution right now, and why?
So let's go to our front end and we can see the statistics. So this is how it's currently distributed. We have Anime v3 get 32.4% of this is actually miners, but it's based off on the Emission. So they actually get 33%, but they have 32.4% of miners or UIDs because there are some validators and such as well. So this model gets 32%, this one gets 28%, this one gets 18%. Then we have some that gets very little. And this is updated on a weekly basis. We do it on a weekly basis, usually just change a few percent, so it's not like too much, and we announce it in advance, so it's kind of clear, and miners have at least a little bit of time to adapt for that.
Do you see that this is super elastic, Victor, in practice? Like you can change this distribution and the miners will just move to it? And how long does that take?
If I announce it beforehand, usually we announce it like 3 hours in advance. And then it's like, if it's a new model, it usually takes a day or two before people like start running it consistently. And that's partly because sometimes when we launch something, not all the validators update at once, so they get less in Emission, they get kicked out and such. But it's very fast. If we would, for example, switch over all models to one of these 3 bigger ones, I think within 24 hours we would be up to full volume, basically, on that miner being on all of them, if all validators would update.
Very cool, Victor. Okay, well, let's continue with your presentation here.
Yeah, thanks. And also, but we do try to keep the changes kind of like reasonable, at least now when we don't have that huge demand. So one of the innovations I really want to share with you is how we have found a way to support both synthetic and organic requests with the same network. Because miners, they are running a certain amount of GPU. They tell us, we can generate 150 images per 10 minutes or something like that. And if a miner says that, if you have just half of that organic query, organic traffic at a certain time period, that means you're like wasting 50% of the compute power, right? Or sometimes it might be only 1% organic, one time 99% organic. So it feels like a waste if it's only organic requests. And if it's only synthetic requests, it's not. Well, if you have lots of use cases for that, it's fine. But we found that you can actually combine them into one subnet, so that you basically take all the organic requests and whatever like compute capacity and rate limit you have left, you use for synthetic requests. So this makes it possible to use it for both like apps for live inference and dataset creations. And the way we do this is by, I'll show this simple example of how we do this. So let's say we have two miners. The first one says, oh, I can generate 5 images per 10-minute interval. Another one says, oh, I can only generate 2. Then we create this like random vector with which each miner occurring the same number of time as the volume they have. So miner 1 is a volume of 5, so the 1 occurs 5 times. The 2 occurs 2 times because it's only 2. So if you get an organic query and someone wants to query miner 2 for some reason, maybe they run a different model, maybe they have higher score or something, then we just remove the first 2 from the list of synthetic requests we're going to send out. So that way, if we will get lots of requests, organic requests to miner 2, we will just remove it from the list and we will send no synthetic requests to it. But we would still be sending synthetic requests to the 1. So this is spread out over a time period. So it's like consistently sending a certain amount of requests. So it's like effectively picking up whatever it has extra in request capacity after it's done like the organic. It just uses that for the synthetic requests. And this is something we're happy to share with other subnets. We think it's worked really good in our experience. And as we will show you later, it also makes a fair distribution between validators based on their tau. I just want to check this.
Yeah, this is interesting. So there you use this queuing structure on the validators, and the miners advertise their capacity. Is that correct? Because you have miner volume 5, and so this kind of exchange system. It's interesting because it was proposed to us a little bit by Adrian Mars a little while ago, where miners can come in and basically say what they can do. And I'm assuming that you're also validating that. So if they're like, I can do 1,000 requests per second, the validators are effectively shit testing that advertisement. Is that correct?
Yeah, exactly. So if you have a validator that has 10% of the tau on the network, you will effectively get 10% of the volume. And then you will. So if the total volume is 1,000, then your validator will send 100 requests per 10-minute interval. So it will basically create this vector with 100. This miner occurring 100 times would use up whatever it uses organically, but the rest synthetically. So it fills up that rate limit. If it goes above that, the miner knows this validator is not worth it. We should blacklist it. But as long as it's within that bound, it's going to accept it. And it's not like discriminating bigger validators or smaller validators, because bigger validators, they will send more requests, but they also give like more weights to the score. So you want to respond to the big ones. Smaller validators, they just send a few requests, but at the same time, you get smaller scores from them.
How does this handshake work where from on the miner side, where they say, well, I'm going to advertise to this validator that I can service this many queries, and advertise to this validator that I can service this many queries. Okay, well, hey, look, there's a slide.
Yeah, so currently validators, they check with the miner every 10 minutes what model they're running and what rate limit they have or volume they set. And based on that volume, everyone knows how much volume each validator has, because the amount of tau each validator has is public. So yeah, that's done like every 10 minutes. The validators check. It's like in a loop. It checks the model. It creates this like vector or queue, and queries it, and then at the end of the loop, it checks again and generates a new queue.
This is interesting, and because you have this queuing structure, Victor, it sounds like you can optimize a lot in terms of the correct bandwidth for the subnet, so you can use all of the resources on the subnet maximally.
Yeah, exactly. And whatever you use.
It is the case right now that miners, if they say that they can service more requests, they're going to get more incentive. And has that driven up the bandwidth of these miners like arbitrarily high? At this point, have you seen that increase over time?
Yeah, we have. So the first thing I want to share is that down here we have this kind of ugly looking thing where we can actually see the volume that they set. We fairly recently implemented this, but basically all new miners they set much higher rate limit, and they slowly replacing the ones with the previous rate limit, which was 40. So we've seen that it's been growing steadily. However, I do want to say one thing here, and it's that right now we're still like easing into the volume incentivization. And if I can quickly go through the incentives, that will become clear. So basically what we do is we incentivize speed through a time penalty. The slower you are, the higher the penalty. And then 20% of the score is multiplied by the volume score. So still, volume is a pretty small part of it. It's more important to have a higher speed. But this is just a variable we could change like at any moment. And when we do that, it will give way more incentive to volume. But right now, it's more to speed. And the reason we have been a little bit hesitant about pumping this up too much is because one, we don't really need the higher rate limit because we're like fulfilling the organic request as it is right now. We're generating like 6 million images or so per day, and we don't have nearly that much organic traffic. So it's just better to have them faster. Second thing is, once we do pump this up, it's gonna drive like a much like faster spiral between miners to compete, to have like the biggest
I would recommend
GPUs.
you do that. I would recommend you do that right now, Victor, because if you have this cap or this asymptote by the looks of it in terms of the thing that you're trying to maximize, the miners won't push into that as much as you'd like. You mean if you want to showcase that you have all of this bandwidth, if you're underweighting the volume so much, how is the subnet going to be performant?
Well, as I said, right now we are fulfilling all the like requests we need, so we think it's fine to prioritize speed. And second thing, I think it's some value in having higher registration costs while we don't really need the extra capacity, because the registration, like the time for registration, that's recycled. That means we can use it later. But yeah, I think we're getting to a point where it's time to crank it up, and I really value your input. That we've tested that it works, and we could like with next update increase it to 1 and see what happens.
So that's an interesting point about the registration costs on the subnet. So you guys are, do you have a high relative registration cost on NicheNet?
Yeah, somewhat high, I would say. I can check it out for you if you. I don't know if I should do this. .com, but yeah, we have a fairly. It's not .com. It's something else.
Your registration rate is 1.12, so that's quite high. And growing.
That's very possible. They're expecting emission increase, maybe.
People, speculating on the Novelty Search podcast. Very interesting. So right now you guys, let's talk about this concept though, about the registration rates and burning tau. So you guys you're pegging this specifically. You're saying, hey, we want to decrease the workload so that we can maximize the burn rate on the subnet as a way of sucking value out of the subnet. And do you think that's working in practice Victor? Like if you do the calculation, is the subnet sucking out a lot of this value?
Just to clarify, like the amount we burn, that means that we're not sucking out any value. Like we're not taking out tau out of the like blockchain. That means we can use it later. So I think actually it's good to have a high tau recycle rate if we don't need the rate limit. But also I want to clarify that this is kind of a new update. So we have been testing this out, but we're also getting to the point where we know that it's worked more certainly. So it also feels safer now to actually crank it up to the max.
Exciting.
I agree. It's so many exciting things happening right now. Can we just shortly comment on the time penalty and volume score calculation?
Sorry, what was that?
Yeah, you had any follow-up question, or should I?
No, this is great. Let's continue. Yeah.
Awesome. And I appreciate the conversations, and I like that you're asking some of the tougher questions, because that's what's most interesting to discuss some of the time.
One of the things that I think is interesting is that you're making an altruistic choice right now with increasing the burn cost on the subnet, because that benefits all tau holders, not just your own subnet. And I don't think I've heard that opinion from a variety of subnet owners, but it's definitely something that's very interesting, and it's very kind, you could say, of the subnet to be like, let's maximize burn so that we can save tau inflation. Tell us more about that.
So I think the math checks out, so to say. Pretty clearly that the less the more we burn, the more we earn, so to say. I think it was a very nice comment about why we should have less volatile registration costs, and that's for the same reason. If it varies too much, the price of registration is not going to reflect the highest value necessarily. So it bounces from 0.5 to 1 tau to register, but the actual value is 0.7, where you should price it at for some people to register, but not all people. If it bounces back and forth, you're going to have less registrations, and so same amount of registrations, but you're just going to burn less for it. So that's why it's better to have this smoother curve, and that's something I've seen other people comment on. So I think that's one example of like the community also doing things to increase the burn cost. Second thing I want to say is that what's so fascinating with the Bittensor structure is that I am actually incentivized to be like altruistic, because like in the end, if I do good things for the network overall, then the validators will see like, oh, they are doing something good on this subnet. We can give them some more weights because we like this. So you would say I'm altruistic. I would say that being altruistic is incentivized. Yeah, through the validators setting the weights on the networks. Do you have any comment on that?
Yeah, well, I definitely understand it. It's something that you have to sell then. So it's good that you're up on stage and telling the community that. I think this is the first stake to NicheNet because you burn more tau. Yeah.
Yeah. Well, maybe not after this if we crank this up, because then what will happen if we crank this up is basically that all the miners, they will compete on volume, and volume is like one way or another, it's gonna come down to how good servers do you have, and that would drive like the price of registration down, because the value isn't in having a miner that much. The value is just having like the highest volume, and for that you need like the best GPUs, which means usually more money. However, here I would just want to mention though that this is also one of the reasons why we should have it decentralized, because when miners compete on something, they will make it better. If anyone can compete, you create a market for it, for this like commodity we call speed and volume, then everyone can compete to drive it down. Like decentralized compute can be much cheaper than if you would have just one data center that sets the prices and you can't really switch from, or if you switch, you have high costs. If we have it decentralized, we can ensure that like, oh, people are going to find the cheapest compute, the fastest compute. They're going to find like the open source repositories to optimize it. And I often see that with miners I talk with, they are like testing out different GPUs options, and they have been moving from, with this recent update, they've been moving on having just one GPU to having like sets of GPUs so they can load balance between and also have higher throughput.
Let's jump to your front end, Victor. Can you show this? Can you showcase? To like show the crowd exactly how this works.
Yeah, so this is the miner dashboard. We also have like the data sets you can see here. So this, like the data set we generated is stored and we can retrieve it. So here is one of the data sets that we can use to train other models, for example, or if you want to create some sort of search database to find valid images, you can do it here. We also have some text model. It's a collaboration with Subnet 22 actually. We took their data sets of tweets, and we ask the model to create articles or summaries about it, to create an up-to-date data set of recent events. So we have that. We have different ways to generate images. You can select the model. We have 4 normal text-to-image model plus a Go Journey.
What's Go Journey? Is that Midjourney?
Kind of. It's a Midjourney at home.
Interesting. Okay, and so people are running a clone of Midjourney. Is that correct?
Yeah, it's hooked up through APIs actually. So this is the currently only API that is being used. So yeah, it's an API from a company that provide an image generation API.
How do you intend to expand the number of image models and the items here just indefinitely? Do you have plans on doing that, Victor?
Oh, so I can't multitask. Let me write this sentence. Yeah. So we have some plans for that, and ultimately we want the demand to drive the emissions and the models that are being run. Once we have added like one category of models, it's very easy to add more similar. So, for example, for these models, it's basically the same algorithm for checking the models. You just need slightly different hyperparameters. So adding it has become easier and easier. But ultimately, what we want is to like talk with what is the demand and see, okay, what is it we should add to the network and scale up and scale down. And for that, we also have an API that validators can create. So they can create their own API that they either can use for their own applications to sell, or we also have an opt-in that some has chosen to join, where they basically share their API access with us, and then we can plug it into APIs and ultimately monetize this, and they would in turn get paid. But it's completely voluntary. Only like 4 validators are actually opted in with that.
And so right now, you guys are selling, or you're finding clients for the API access, correct?
Yeah, we have a few partnerships that can go through. First one I will talk about is we're building actually a data set for training a new cutting edge image generation model. The image you can see here, it's generated with that one. We call it Proteus BT for Bittensor. So yeah, we're partnering with them to create this new model. This is an early version. We'll release it in May. So yeah, that is one of the use cases. We're also working with Taobot. They're making it available through their app. I told you about the data augmentation of the tweets. And also we have this is actually a new announcement now. We're announcing a partnership with Social Tensor. They have this site called Make It a Quote, where you basically can insert any tweet and they automatically turn it to a quote. So we'll plug in the API here so they can generate an image. So that's some of the people we are working with now. We're in the works with some more platforms and apps that we will announce. Well, we'll announce when it's ready.
Proteus BT, these guys, you said you're building a synthetic data set in order to train a model. Is that correct?
Yes, exactly.
And I'm imagining that the fact that you're doing niche models is positive for that, right, Victor? Because you have a variety of different models, and you can then use that to build a very broad synthetic data set. And how big is the data set that you've generated so far?
I'm not entirely sure how big it is. Also, there's only like 4 or maybe 5 validators that has opted in to share their like API with us. And if they don't share it, we can't force any validator. Some subnets, they have done it so that they automatically share their data sets with like the subnet owner, but we chose to do it an opt-in. So my guess is we have a few 100,000 images, but like we generate 6 million images per day. So in the hundreds of thousands is like relatively like not huge amount. Though to train a model from scratch, you only need like 5 million images. So the way we're doing it with the data set is actually we will generate a very large data set of high quality images, and then we actually run different models on these to judge, for example, okay, how good is the prompt alignment and how aesthetically pleasing is it? So that way we can also sort like, oh, these are the best 10% of images. And there's no direct incentive for miners to generate better images, at least not right now, which means that they're not like going to game it because they don't care. But we can afterward apply these like filters to the data set so we can get only the best. And if you have different categories, it's likely that, for example, the Reality's Edge model will create most of the super realistic images, while maybe the anime will create the best animated images or something like that. So that way we can, as I said, get different models depending on what category and have this varied data set with high quality images with a broad stylistic range. The next step of that would be to integrate multiple LoRa's. And if you don't know, for those that don't know what a LoRa is when you basically fine tune an image model, but you only change like 0.1% of the weights. So you only change like 0.1% of the model, but you can make it really, really good at like one specific style or one specific type of image. And once we get that integrated, we will also be able to, with the same models, support a huge amount of styles and such that feeds into this recursive loop of better data sets and leading to better models that leads to even better images, that it's better data sets and so on.
And that would be something that your net specifically could be good at, Victor, because of its diversity.
Yes, exactly. So I think this partnership is very, very exciting for us. We got some positive feedback from Twitter also. So people seem to like the model, like what we've shown so far from it as well. So it's exciting that if they like it now, wait until they see the final thing.
Great. And okay, so let's going on, Victor, do you have any more slides here for us?
Yeah, I think I'm pretty flexible, but I don't think I went over this with the time penalty. But I just want to go through the neat way we solved. How do you incentivize consistency of time? So it's like the most straightforward way to do a time penalty is basically the slower, the higher penalty, and have it be linear. But that is not really useful because for many use cases, you rather get an image after 3 seconds every time rather than after 2 seconds some of the time and 7 seconds some of the time, because you don't want to have that variability, right?
Right.
So the way we do this is by just having the processing time in cube and the max time in cube. That means that the penalty is actually growing more than at a linear rate, meaning that if you go from 2 to 3 seconds, it's not that bad. But if you go to 3 to 4, it's worse. That way, you rather want to load balance as efficiently as possible to get these consistently fast processing times, rather than having it a bit all over the place. So you try to avoid queues. So that's a nice way to incentivize that I think many networks could implement. Next thing is volume scores, and this is more for the transitionary phase. It's just that it's possible to cover a very wide range of volumes that can be set by a miner if we have it be growing at to the power of 0.5. Because if it would be completely linear, it would be very hard to set a set of volume that is scored well as the network grows, because then we would have to update it when people go from 40 to 100 and 100 to 200. We have to change the volume scoring all the time. But this way we can score everything from 40 to probably 2,000 or 3,000 or at least 1,000 in volume. So yeah, that's worth keeping in mind for everyone wanting to incentivize consistently fast time and also implement this volume score. Yeah.
It would be really amazing to see some images of this loss landscape niche at some point, and more than just equations, but also to visualize what you're actually doing when it comes to incentivizing speed, time, volume, etc. And if you could produce some statistics for the community on how that actually plays out, because it's interesting science that you're doing, but it's hard to actually understand exactly what these equations are when we're just seeing them on the screen.
Yeah, I can understand that. I'll keep that in mind. Next presentation, I'll try to have some visual aid. But basically, consistently fast time and covering a higher volume is the main takeaway from here.
And this will be really useful for your clients, you said. So like Social Tensor and Proteus, they're asking for speed and rather than volume. Is that why you're pushing this direction?
Yeah. So for the inference, the speed is very important. So Taobot and Social Tensor, they want their users to get an image as fast as possible, because they are organic requests. But the data for Proteus, that's synthetic. We're building a data set, so it doesn't really matter if it's fast or slow. So maybe if we notice this specific model is really, really good for data generation, let's incentivize volume more and speed less. because here we just want a big data set. We don't care if it takes 20 seconds or 2 minutes to generate an image. That allows them to have bigger batches, which takes longer time total, but it's more efficient per image. Because right now we haven't divided up into those niches yet that much. It's a little bit difference between models, but once we find out okay, this is the setup, then we will have different models for different use cases. So this one will be mainly for data generation. This other one will be mainly for a inference, let's say. Even if it's the same model, by the way. Maybe it's the same model as the best of both of these, but you can still have two emission pools for them. So some do it really fast and some do it really high volume.
Great, Victor. And let's move on.
Yeah, I think I've covered most of the things I want to cover. Just a brief overview of the roadmap. Right now, we will be focusing a lot on pushing things more to production, get more usage. The first thing we'll do is upgrade the API and API docs, so it's that simple for anyone who's curious to just get an API key and try it out. We'll add additional LLMs because the recipe is basically the same. We check the output. We have the same scoring for time and volume. And right now we have a pretty small model, but I think some would just like to have a big model, maybe Llama 3. Release of Proteus BT is planned for May. That's something. We're going to completely do a do-over on the UI, more functionality, better usability. To really make it accessible. Long term, we have this exciting plan, which was actually the original idea behind the subnet, or one of the original ideas. And it's to, in addition to having these fixed models, we could have some open categories where we actually score the model. So a bit like Subnet 1, but depending on what type of niche we want, we can have different scoring. So we can create subnets within the subnets. And if it's, for example, for a synthetic data set, we can make it so that, we score based on this thing that we know makes better data. But we chose to leave this off for a bit because we thought we want now the consistency of fixed models, but this is something we will do in the future. And ideally make it so simple that even if you only need 100,000 images to fine tune a model, you could set up your own category to get a data set to train LoRa's for an image model to get exactly what you want.
And Victor, before we close off here, I can see this is the last slide. Who is we?
Yeah, amazing question. So it's we are 4 developers in the core team. It's me, William, it's Duang, and Tan. So 3 of us have a background in machine learning. My background is more in text, so it's William's. What?
Your background is in Bittensor.
Yeah, of course. But Bittensor is also machine learning. It's the intersection of AI and blockchain, I would say.
Are you intending on growing that team, Victor?
So for the development side, probably. So we're probably gonna expand the other team, the sales and front end building team and such. But I think that we are the core developers behind the repository. We do the core mechanics, and I think 4 people working with the repository, or at least the core functionality of it, is a good number, at least for now. In my experience, like what 4 developers can do in 4 days, 10 developers can do in 10 days, a little bit, if the area is small. But yeah, we're working with a front end and a designer, and also bringing in like a dedicated salesperson. So we're growing like that part of the team. But the core team, I think, for now will remain at 4 people for like the repository development.
Very exciting, Victor, and thanks for coming on the stage here and showing us what NicheNet's doing. I'm really looking forward to seeing this model that you guys are going to train and also making easy to use APIs and docs. I think that getting people to use the subnets, whether it's validators or just general users, is a huge requirement just to showcase that it works, and from that you can get the right feedback to making sure that you're tuning these hyperparameters properly to get the things that are required for your clients.
Absolutely, and that's something that the guys at Datapulse also said, that if we get like user feedback, they also have a Discord bot that is very popular. And if we like, the more user feedback we get, the better we can build the product.
It looks like Zion's giving you a shout out. I know that you've done a lot in the community niche, and he's shouting out for the help that you gave him.
Yeah, thank you, Zion. Appreciate it.